Quantum breakthrough. New method preserves information against all odds. Think of the initial swirling patterns that appear when you add cream to your morning coffee, said Nandkishore, senior author of the new study. Imagine if these patterns continued to swirl and dance no matter how long you watched. Researchers still need to run experiments in the lab to make sure that these never-ending swirls really are possible. But the group's results are a major step forward for physicists seeking to create materials that remain out of balance, or equilibrium, for long periods of time, a pursuit known as ergodicity breaking. The team's findings were recently published in the journal Physical Review Letters. Quantum memory. The study, which includes co-authors David Stephen and Oliver Hart, post-doctoral researchers in physics at CU Boulder, hinges on a common problem in quantum computing. Normal computers run on bits, which take the form of zeros or ones. Nandkishore explained that quantum computers, in contrast, employ qubits, which can exist as 0, 1 or, through the strangeness of quantum physics, 0 and 1 at the same time. Engineers have made qubits out of a wide range of things, including individual atoms trapped by lasers or tiny devices called superconductors. But just like that cup of coffee, qubits can become easily mixed up. If you flip, for example, all of your qubits to 1, they'll eventually flip back and forth until the entire chip becomes a disorganized mess. In the new research, Nandkishore and his colleagues may have figured a way around that tendency toward mixing. The group calculated that if scientists arrange qubits into particular patterns, these assemblages will retain their information, even if you disturb them using a magnetic field or a similar disruption. That could, the physicist said, allow engineers to build devices with a kind of quantum memory. This could be a way of storing information, he said. You would write information into these patterns, and the information couldn't be degraded. Tapping into geometry. In the study, the researchers used mathematical modeling tools to envision an array of hundreds to thousands of qubits arranged in a checkerboard-like pattern. The trick, they discovered, was to stuff the qubits into a tight spot. If qubits get close enough together, Nandkishore explained, they can influence the behavior of their neighbors, almost like a crowd of people trying to squeeze themselves into a telephone booth. Some of those people might be standing upright or on their heads, but they can't flip the other way without pushing on everyone else. The researchers calculated that if they arranged these patterns in just the right way, those patterns might flow around a quantum computer chip and never degrade, much like those clouds of cream swirling forever in your coffee. The wonderful thing about this study is that we discovered that we could understand this fundamental phenomenon through what is almost simple geometry, Nandkishore said. The team's findings could influence a lot more than just quantum computers. Nandkishore explained that almost everything in the universe, from cups of coffee to vast oceans, tends to move toward what scientists call thermal equilibrium. If you drop an ice cube into your mug, for example, heat from your coffee will melt the ice, eventually forming a liquid with a uniform temperature. His new findings, however, join a growing body of research that suggests that some small organizations of matter can resist that equilibrium, seemingly breaking some of the most immutable laws of the universe. We're not going to have to redo our math for ice and water, Nandkishore said. The field of mathematics that we call statistical physics is incredibly successful for describing things we encounter in everyday life. But there are settings where maybe it doesn't apply.